Hey everyone, today we're going to be looking at phase energy. Now we've already talked about thermal energy, which is the total amount of energy stored in the particles of a substance, and we said that there are different accounts that you can store energy in, but thermal had been the only type of energy we had talked about. Now we're going to talk about the next type, which is phase energy. And so here in front of you, you see solid argon. It's keeping its shape. If we look at each particle, they're attached to the particles next to it so that it won't flow around and it keeps its shape. And I'm just going to move it back to the center here. What we're going to look at now is what happens when we add heat to it. Well, just as we'd expect, the particles start moving faster and faster, and there comes a point where they start being less attached to the ones next to them, and they can spread out and flow as a liquid, which is what you see here. What we're interested in is that transition, right from where it goes from a solid to a gas, because something interesting happens. The argon will actually stop heating up at that point. There'll be a brief amount of time while this turns into a liquid where the temperature, that is the thermal energy, because they're related in this case, does not increase. And instead, all that heat that I'm adding, which is really just energy, so when I'm heating this up, I'm just adding energy to it, that energy is used to break apart the connections between those individual atoms. So if we look at a solid, like let's say that one right there, notice how it's connected to all those around it. In a liquid, if you pick one, yes, it's connected to the ones around it, but those connections can change. They're not as strong as they are in a solid. And so there comes a time when we're transitioning from solid to liquid where we're just changing the strength of those connections. And the energy that's stored in those connections is called phase energy. Now with phase energy, the more phase energy you have, the less connected the particles are. So solids have the least amount of phase energy because they're very connected. Liquids are less connected and so have more phase energy. And gases aren't connected at all, so they're going to have the most amount of phase energy. And what we're going to look at next is how to do a lull diagram that will help you figure out how to see what's going on in this and maybe make this make a little more sense. So now we're looking to make our lull diagram, our LOL diagram of this phase change. So here we've got a hot plate with boiling water on it, and we're going to look at what happens when this changes from a liquid to a gas. So we're going to draw the parts of our lull diagram. And we're first going to decide on our system. The thing we're interested in is the thing that's changing phase. So in this case, our system will be just the water. And we're looking now at two types of energy. ETH, which is thermal energy, and EPH, the phase energy. And we're going to be looking at that for both of these. All right, next up, let's look at the amount of thermal energy in the water just as it starts boiling. Now, we're not tied to any particular amount, so I'm just going to pick something we can work with, and I'm going to give it 3 bars of thermal energy. And remember, this is our initial setting, just in case we've forgotten. So this is water, and this is our final, which is going to be steam. I'll throw that in there so that we don't forget. Alright, so we've got a certain amount of thermal energy, and let's talk about the phase energy for the liquid water. Remember, solids have the least amount of phase energy, and then liquids, and then gases. So just as a way to conveniently mark this, we'll always have solids with 1 block, liquids with 2, and gases with 3. So This is liquid, so we'll give it 2 bars of phase energy. Now, this hot plate is continually adding energy in, so we'll draw an arrow showing that energy is being added to the system, and we'll mark that this is from the hot plate. And now let's talk about what happens afterwards. This energy has to go somewhere, so we have to add it to either our thermal energy or our phase energy accounts. Well, we know that during a phase change, when water goes from, say, a liquid to a gas, or from whatever phase change, it really doesn't matter, we know that temperature doesn't change. And in this little graph, our temperature is related to our thermal energy. So during a phase change, temperature doesn't change, so our thermal energy has to stay the same. So the only place that this energy that we added could go to is in our phase energy. And so we have to add another block onto that. And so now we can see that our phase energy increased from 2 blocks to 3 blocks, which would make sense. We said the more phase energy it has, the higher the energy of the system. So solids have the least, liquids have the next most, and then gases have the most. So this diagram shows us that the temperature doesn't change, energy is added in, and that energy goes into breaking apart the attractions between the particles, which we call the phase energy.